Good afternoon and welcome to our new product presentation. We are going to talk about new version 7 of OpenE data storage software today. We have prepared very simple setup for you in order to show how Active-Active Failover or iSCSI Failover works. So we have two servers, first with 4 network interface cards or ports interfaces and another one as well. So the IP addresses are, as you see, 192.168.0.220, 2 and 3 220, and here on opposite side 0, 1, 2, 3, 221, 221, 221. So we are going to use ETH1 for volume replication. On our chart we show path over the switches, but we do strongly recommend to use a point-to-point connection between both cluster nodes. Okay. The ETH2 and ETH3 will be working as a storage access ports, so on both we have created virtual IP addresses. In this case, it is not meant for multipath. It is meant to access 2 separate volumes over 2 separate network interfaces. Okay, for multipath we will need to another 2, for example, if we need a multipath with 2 paths. Okay, so we have also shown that there are 2 block I/O volumes, and there is a replication, 2 tasks replication, which are replicating both volumes. We will show in the web GUI right now, so it will be maybe easier to understand. We are going to create also 2 ping nodes, and then in the LAN we will have some kind of storage clients. In our presentation we are just going to use a ping to see whether we have access to the cluster or what happens when we are moving activities of one volume from one server to another one. Okay, that's our GUI version 7, and I have already created logical volumes to speed up the presentation. So on the first server is I renamed to DSS 220 and the second to 221. Okay, so on the second server we have 2 logical volumes, and we have already put the source and destination in the proper place. Same on the primary. So on the primary, maybe we call it primary, let us call it node A, because there is no really primary secondary server in the Active-Active version. Both can work as a primary, because some of the volumes can be active on every server. So as you see, we have in order to show the Active-Active, we need at least 2 logical volumes. If we have 1 logical volume, that will be just an active-passive configuration. And then when we have 2 logical volumes, then the first can be active on the node A, and the second can be active on node B. Okay, and then both will export over separated virtual IP addresses. We can have, of course, more volumes. We can have, let's say, 20 volumes, and then 10 volumes export make active on the node A, and another 10 make active on the node B. It don't need to be 10, 10. It can be, let's say, 5 and 15. Doesn't matter. Okay, so we see we have 2 logical volumes. First, a very small one I created for 50 gig and 60 gig. How to create a volume, it is not our goal for this presentation, because we have too little time. Okay, so in the volume replication on node A or DSS 220, you may see that I have already selected source for LV00. So on the node A, the LV00 is in a source mode, but logical volume 01 is in the destination mode. So when we go to the server DSS 221, so node B, we see that the volume 00 is in destination mode here, but the volume 01, it is in a source volume mode here. So now we will create the so-called replication task for every volume. So on the volume 00, the replication task at home will be created on the node A, and for the second volume, replication task will be created on the node B, so on the DS221. So I switch to DS220, DS220, and the first new thing which we have in DSS V7, now we have a function which is called host binding. So let us enter the IP address of the opposite side, and here be careful, this IP address is exactly the path which will be used for volume replication. So because in our case we have decided that this ETH1 will be used for replication, so we'll use the path segment 1. Okay, so I'm on server 220, then I need the IP address from segment 1, and that will be 221. So 192.168.1.221. Okay, and we also asked for the administrator password of the GUI of the from the second server. So admin. That's my factory default password so far. So we are binding both nodes, and both nodes will be able to replace the config files, and they will be able to work in the cluster later on. But the first thing which will allow us to create the replication tasks, it's a binding. So that's the first step before we create the replication task. Okay, even if you will not create a failover setup, we still need to bind both modes for the volume replication. So on the node A, so the DSS 220, I will just enter M for mirror and then 0. That's enough for my name. I can also put a mirror if I want. The task name is not so really important, and we will use LV00 on both sides, of course. And here the bandwidth, so same rules and VS in V6. So if we have 1 gigabit, so you can predict that will be something like 100 megabytes per second. So for 2 tasks we can put 50-50. So when you will have the more tasks, let's say 10 tasks and 100 megabytes per second, so please put 10 megabytes per every task. If you need better performance, please use 10 gigabit Ethernet. Okay, so we are creating tasks on node A. The task is created and we are ready to start. So let us start the volume replication task on node A. Because both volumes were created new from scratch, so the status will show consistency at once after the replication task is started. If the volumes were created not at the same time, the volume replication will need to initialize. So we need to copy all data from source to destination. So task is started. We see this in the event viewer. Okay, we also can see in the status, so task status, where consistency is already reached. Yes, so the task is, as you see, in consistent state. So the volume on the destination is in consistent state. Good. So that was the volume replication on node A, and now we need to do the same on node B. So here we see the LV0001 is in the source mode, so we are ready to create a task for the logical volume 01. So mirror, let's say 1, okay? And here I can put also 50 megabytes per second as a limit. So after creating the task, I will need to start the task here as well. So we see that the mirror reverse, it was automatically created task while creating a mirror on the node A, and now we have a mirror 1, and on node A we will have also a mirror 1 reverse, which is automatically created. This is between this is for moving activities between modes, okay, between both nodes. So now mirror 1 is a home task for node B, and we need to start it here, okay. So now we will have one source volume on every node. Okay. So after starting and proving that everything is okay, we need to export both volumes over iSCSI targets. I have already created the targets, so to make it faster, target 0 alias, that's the name of the target. We can see when we go inside and edit, we can see the target name here on top, and we can see the target name here in rename function. Okay, I can rename it, and you see I just have a almost default name, IQN 2012-07, that's for month, and then colon target 0, and exactly the same name I was using on the node B. Okay, so when I go to targets, then we will see when it shows that we have exactly the same name. We see here in the top bar that's the same name, and also that's the SCSI ID. SCSI ID, it starts with T and finish with U, and when I go here it starts with T, finish with U. It's exactly the same SCSI ID. I was just copying paste while creating. So same is on the second target. Okay, so we have both targets already created and binded with the logical volume, so the plus button was clicked, and both targets are, both logical units are exported over these targets. Okay, next step will be just configuring the failover. So in the setup failover, we have new functions, and these new functions will work this way, that both nodes will be configured only from one node. So I can do configuration from node A, and I can do the same from node B. So I'm free to choose on which node I will follow up with the failover configuration. Okay, so let us do it on node A. So we have here a few steps to fill in. The auxiliary parts, that's the path for the heartbeat, and here we have decided to have the heartbeat already automatically on the replication. It was created automatically, and we want heartbeat connection on every storage access card. So on these cards where virtual IP address is working. So we just need to edit. So first will be subnet 2. Okay, I'm selecting both ports, ETH2 on both sides. And next one we want on subnet 3. So we need to select 192.168.3.220 and 3.221. Okay. That is the second path, and then one more in subnet 3. Okay. Next step, that will be a ping node. So we have decided to have 2 ping nodes, and you see that's in subnet 2 and subnet 3. So the subnet 2 and subnet 3, that's exactly the cards on which we will have the storage access. So in this subnet you need a ping node. I was creating ping nodes on my VMware server here, so they are already active and working. So when I configure this, we will have the answer. Okay. Next step is a ping node. For our demo, it will be enough if I add a 1 ping node. It is enough to start the cluster. Okay, that's the first ping node. And we can add a second ping node also. In our case, it will be enough if I adding 1, and then we can already start do the next step. Aha. So I see already. Aha, this is reachable right now. Okay. So next step, that will be the last step already. We need to configure virtual IPs and select iSCSI targets for our resource pool. So virtual IPs are like here, so 192.168.20 and 30. Okay, you see that's the different subnet. Let us configure this fast. So 192.168.20, and then I was deciding to put 100, so looks nice. And this is in subnet 2. Okay. And mask. Okay, that's enough. Okay, edit. So we are adding the first virtual IP. The second virtual IP, that will be on the ETH3 on both sides, and that will be 192.168.30.100. Okay. And you see we have a resource pool of the local node, and we have a resource pool of the remote node. In the resource pool, we define virtual IP, and we will select which iSCSI target belongs to this resource pool. And everything what is in this resource pool can be, as a resource, can be moved to another node. So now we have virtual IP. We can add target. So target 0 is the one which belongs to a resource pool on the node A. Okay, and another virtual IP and another second target will be configured on the resource pool of the remote. If I will switch to another server, I will have, of course, opposite. The first will be my local resource, and the second will be remote resource. We can show it here as well. So that's DSS. I maybe forgotten to mention that there is here we recognize servers on so-called host name, and this host name needs to be changed. That will be good idea to change the host name, and you can change it under setup network interfaces. The default host name will be the DSS and a number. So you can put, let's say, node A instead of DSS and leave it the number, because every node in a cluster must have the unique host name. So in order to recognize the hosts easily, like host A, host B, or host 220 or host 221, you can put, let's say, node A instead of DSS, and then leave this number, and after apply, it will need to reboot the server. So after rebooting the server, the hosts will be having a name which you can easily recognize here, right? DSS 18 something. It is not giving us, it is not so easy to recognize whether it is node A or B. Okay, so now for this resource pool, local resource pool, we have defined the target and we have defined the virtual IP. Same thing, it will be already enough when we'll have just a regular active-passive mode. Then we'll be able to start the cluster already. But now we show active-active, so that's the difference, that also you can define resource pool on the remote node, and this can be moved independently. So I add virtual IP 192.168 and this time 30.100. I'm select the NIC from subnet 3, netmask. Okay, and just add it. And the very last thing what we need to do is add the target. After this, we are ready to start the cluster. Please note that as long as the cluster is not started, the virtual IP are not activated. So we are waiting here for the cluster to be ready to start, and I can start some pings. I have prepared already shortcut to ping, and you see the both are just when I'm pinging the virtual IPs. Do I'm pinging the proper? Yes, I'm pinging proper. So when I'm pinging this one, but 11 is my IP, okay? So I'm pinging this virtual IP, it is unreachable. Okay, so now we are ready to start. Sorry, I forgotten. We just need to add the iSCSI target. Okay. And that was the last step. After adding the iSCSI target, we are ready to start our cluster. On the top, now it is ready for start. Okay, so I can just prove that everything is done. So we must see the mode sync on the both sides. Okay, so we are ready to start. Let us click on start. I will also start the both ping. Okay. During starting, both virtual IP are still not available. Okay, maybe make a bit bigger. Okay, there is some change already on the secondary. I see the virtual IP is started, but on the primary, not yet. Okay, then we have a problem. Did I really configure everything properly? So 192.168.20.100, everything is there, but we don't have the answer. Okay, what's wrong? Aha. I see already the problem. So we need to stop the cluster. I make a mistake configuring the volumes, configuring the iSCSI, virtual IP. I select here the subnet 1. That is the reason why it is not reachable. Okay, so we need to stop the cluster, and this mistake will cost me that I will probably make one more session. Okay, so we can edit this. Okay, and we can edit and apply this properly. The second virtual IP now is not answering as well because our cluster is stopped. Okay, but you see the ping is very nice tool in order to troubleshoot whether everything works well. So you can see it almost at once. Exactly. So now it's 220 to 221. So it must be no more such a surprise. We are starting, okay, then we can try one more time, okay? I will just mention that in this active-active mode, the cluster behaves like you will have the almost two separate servers. Every server will give you some storage resources, right? And these servers are binded and each other and replicating each other, and they are ready, that another one will take over, okay? But they are working like, simulating two separate servers, okay? So here now we have the answer from the both nodes, and the cluster was just checking the status, and now I see the status is active. The DSS local node has an active volume on the local node, and there is one more resource which is active on remote node. If we want to see the details, we can just go the details, and then it will move us to the resource pool manager. So here, look, we have this move to remote and move to local, because first resource pool is active on local, and the second resource pool is active on remote. Okay, so let us try how the failover failback works. So now when I want to make failover, so manual failover of the resource pool on the node A, so I just click on move to remote, confirm, and now it is moving the first resource pool activity to the remote. We see some ping lost, okay, and after ping lost, everything is already restarted and everything works on the second. Okay, when I see the messages that the resources were moved successfully. So now, when I go to my iSCSI cluster status, I will see that the first resource pool is active on the remote node and the second as well. Okay, so we can switch it back. So now the second I can move to the local. So I will have an opposite situation as started. So as start at home was that the first logical volume was active on the node DSS 220, and the second was active on DSS 221. Now we have a just opposite situation. So you see that was the time when it was moving. And now we can also come back to the first starting situation. I can move it back to the local. Okay. Okay, that's already happened here. And same thing with the logical volume 01. Now both are active on the local node, right? So let us move the second resource back to remote, and then we are in the starting situation. Of course, we can reboot the servers, or we can also power off the servers to try how the cluster is working, and you can also connect some storage client and install some virtual machines and see how it behaves.